Uh, These are the business rules we came up with for our project. Came up with each bellman must sign in when their shift starts, and then they sign off when they leave. Only bellmen that are currently at work can be assigned tasks. A bellman must be assigned to a task at all times unless that bellman is on break or there are no available tasks. A task of a name, location, a task consists of a name, location, status, and comments. A bellman can be assigned multiple tasks at a time. A bellman can be uniquely identified by their identification number. A bellman is considered busy if that bellman is currently working on a task or is on break. And every task must be assigned to at least one employee. For each task assigned to a bellman, the time of assignment must be recorded and the time taken for each task must be calculated. A report with the time worked by each bellman will be needed at the end of each day. The bellman needs to be able to mark a task as complete, and there can be many bellmen in a queue. There is only one bellman queue. So our ER diagrams went through multiple revisions in order to meet the goals of our project, as well as our solution goals for the initial problem. This is our first ER diagram. We found it to be too simplistic and it didn't meet all the requirements for our project, as well as fulfilling all our initial business rules that we came up with. It was only composed of a queue, bellman, and task. This is our second revision. It was still too simplistic, so we added the assignment entity because we needed more data relevant to the task being assigned to the bellman. And then we came up with this final diagram. This diagram has all the same entities as the previous ones, except we added in a time card that adds in some extra time data, as well as two sub-entities that are subpart of task. This is our table schema that goes off of that ER diagram. You see it was composed of 7 tables. The first one is time card, which holds employee ID and date both as the primary key, and then time in and time out of the day that the employee worked. Employee is our main table. Its primary key is employee ID. It holds the name of the bellman, the status, whether they're busy or unavailable. At work lets us know if they're at work or not at work, and then the queue value. The queue value is held in the bellman queue, which holds their ID. The bellman queue is built based off of a priority system. Then we have task. The task ID is the primary key. There's a type of task. We came up with 3 different types: check-in, check-out, or room change. There's also the location of which the task will be taking place, which would be the room number the bellman is assigned to. There's a task state, which is whether it's finished or unfinished, which also helps us with our sub-entities. And then further comments we wanted to add to the task. Assignment helps us relate the task to the bellman, whichever employee took the task. So that's why the primary key is composed of both the employee ID and task ID. And then we also put an assigned time there so we know when the assignment was actually made. The 2 sub-entities are finished task and current task. If the task is finished, it has a completion time. If it's current, it shows the status of where, if it's either being worked on or if it still needs to be assigned to another bellman.